or physical education, and the director claims that this vitamin is for weightlifters can increase their strength. So 8 athletes are selected, and they're given a test of strength using a standard bench press. After 2 weeks of regular training and supplement with the vitamin, they are tested again. We want to test the effectiveness of this vitamin regimen at an alpha equals 0.05. Each value of the data represents a maximum number of pounds the athlete can bench press, and then we want to assume that it's approximately normally distributed. So we have a before and after situation. So each data point, the one before is the same measurement on the same person as after, and we want to know what is happening with them. So if I want to know that, I'm going to kind of extend the table to get the rest of the results that I want. And we want to do x1 minus x2 across the board. So I want to subtract for each column. This is going to give me all of my d's, where the d was the x1 minus that x2. So 210 minus 219. Negative 9. Then I want to do 230 divided, or minus 236, negative 6. 182 minus 179. 105 minus 104 gives me 1. Sorry, 205. 205 minus 204. 262 minus 270. 253 minus 250. 219 minus 222. And 216 minus 216 gives me 0. So to find the mean, I need to add up all of these differences. So let's add up that row and see what we get. Negative 19. And then I can say that my d bar, which is the sum of the d's divided by n, is going to be negative 19 divided by, how many differences do we have? 8. So your d bar is going to equal negative 19 divided by 8, which gives me negative 2.375. So that's part of the information that I need. Then I need the standard deviation, so I'm going to find the d squared, which is all the numbers above just squared. So 9 squared is 81, 6 squared is 36, 3 squared is 9, 1 squared is 1, 8 squared is 64, then I have 9, 9, and 0. I'm squaring all the values in the first set of blue. But the standard deviation says that you need the sum of that row as well. So let's add up all those squared numbers and see what we get. This is going to help me find the standard deviation and the variance.
So you're adding all those up?
I'm adding all those up. Mm-hmm. $209. All right, now that's only a piece of what I need. So I'm going to come down here and try to fill in my formula, which says I need to do n times the sum of the d squareds. And this, 209, is the sum of those d squareds. So my n is 8. So I've got 8 times 209. And then I want to subtract the sum of my d's, so the ones that I didn't square, which was negative 19, and you want to square it after you have that sum. So we'll square the negative 19. And then we want to divide by n times n minus 1. So 8 times 8 minus 1, or you could just put 7 there. With the square root of all of that, I'm going to get my standard deviation. If I did the formula without the square root, it would give me the variance. But in order to get my test statistic, I only need the standard deviation. So let's see what we get for that. All right. So I should have all the pieces that I need in order to do the test statistic. So now that I've got all my information collected, let's go back and figure out what our hypothesis is supposed to be. So my null is supposed to be that mu d equals 0. That's just a given every time. So, and we have that mu d is equal to your mu 1 minus your mu 2. So we've taken the mean of the befores and the mean of the afters and subtracted them, and we're assuming that they're equal. So we're assuming that nothing has happened from the supplement of the vitamin, and so they're just equal to one another. Now, they asked me to test the claim that the vitamin regimen is effective, right? If, yes. Right. They would mean effectiveness would mean if it's effective, you should be able to lift more, right? So if that's the case, if you can lift more after, your after weights are greater, and your before minus your after, would they be a positive or a negative result? Negative. So when you're putting it in your hypothesis, what sign do you want? Should you be less than 0 or greater than 0? Less than 0, because your mean difference should actually be negative. So it's a little bit confusing when they're talking about the effectiveness when you want your after to go up. It's not as intuitive because you want to put a greater than sign, but you would actually have smaller numbers because your after weights would be smaller or would be larger and your subtracted would be negative. So if it is effective, then that puts your claim in the alternative. All right, questions on that? Because I always think that's a little confusing. It is. It's a lot. Are there questions that I can do to help? You can do in the calculator. So it is a less than test. So let's find, it's a one-tailed test, so that means that alpha, which is 0.05, is all in one tail. So we're going to find a t of alpha, and we're going to use the amount of matched pairs we have for our degrees of freedom. So we're going to use the n, which is 8, and say 8 minus 1 to get 7 degrees of freedom. So let's go figure out what our critical value should be. With 7 degrees of freedom and 0.05 in one tail, we are looking at a critical value of 1.895. So I've got 1.895, and since I'm doing a left-tailed test, that value should actually be negative. So even though your table gives you the positive, it is a symmetric distribution, and we should have negative 1.895 as our cutoff value. So if we land in that tail, we reject. If we don't land in that tail, we have to fail to reject. We have all the pieces to create our t-test statistic. So let's go ahead and use it. My mu d was negative 2.375. Then we have, our d bar was the negative 2.375. Mu d is assuming that they're equal, so we would subtract 0. You can put the 0 or not put it, either way. And the formula says to take your S sub D, your standard deviation we created, which is 4.84, and divide it by the square root of 8. Let's work that out and see what we get for our t-test statistic. 1.39. So if that's my test statistic, it is in here. And what would we say about this study? Fail to reject. So I'm rejecting or failing to reject the null, which means I did not get to the point where I would accept the alternative. So what would I say about this? Is there sufficient or insufficient? All right, so there is insufficient evidence, to support the claim that the vitamin regimen or vitamin supplement is effective. Because we would have to get into that alternative to say that it is effective. Yes? Because we're not looking at our test statistic being less than 0. Our test statistic has to be less than our critical value. And it wasn't out there past our critical value. Other questions? Know that the cholesterol level has changed. Well, the null hypothesis still has to be that the difference mean is equal to 0. What's going to be the alternative? What does change go along with? Not equal. And that's also where your claim is. Now, to use technology, I want to put my befores in L1 and my afters in L2. So let's start with that. And make sure you get all the data out of each list before you enter in this information. Otherwise, you might have extra data that we don't really want in there. All right, did everybody get your data entered? Okay, so I want you to clear your list 3. And then I want you to go back and look at how my list 3 is highlighted. I have my cursor over top of list 3. Oh, that's a good point. That could minorly throw off my results. All right, so then let's go back and highlight that list 3. Now, it has to be highlighted up at the top or it won't work. But then I want to tell it L1 minus L2 for that portion. So it'll type it in as that's what I want L3 to equal. So it's going to be the befores minus your afters. And if you just hit enter, it's, yes.
L2 minus L1?
L1 minus L2. Your before weights minus your after. And if you hit enter, it's going to fill in all your differences for you. And over to test. And since it's only one list of data, that difference list, we're going to do a t-test with data. Now your mu-d Your null hypothesis says